Thank you for joining us for today's webinar on glTF Complex Scenes and Interactivity. Our presenters today are Dan Frith from Avataar, Gerald Guyomard from Adobe, and Leonard Daly from Daly Realism. First, a couple of housekeeping items. If you have any questions during the presentation, please ask them using the Q&A feature located on your Zoom toolbar at the bottom of your screen. We are recording this webinar and we'll share the link along with the slides and the recording later this week. At the end of the session, please complete the short survey form to help us better design future events. With that, I'll hand it over to Dan Frith, Vice President of 3D at Avataar and 3D Commerce Working Group Chair. Dan?
Thanks, Jeff. Thanks for that lovely intro. Hello, everybody. As Jeff very nicely said, my name is Daniel Frith. I'm Vice President of 3D at Avataar. I'm also chair of the 3D Commerce in the Kronos Working Group and vice chair of 3D Formats Working Group. Today, we'd like to take you through, I'm going to take you through 3D Commerce and some use cases, and then Gerald's going to take interactivity, and then there's going to talk about how that all pieces together. But first, we're going to talk about, the next slide, please, Lizzie. I'm going to talk about Kronos's ecosystem segmentation. And so Kronos has multiple standards and often relevant to developers, as this says, with similar requirements. And Kronos currently identifies 6 such market segments, and these working groups within a segment coordinate and cooperate together to develop coherent solutions and outreach programs. Next slide, please. And then today, we're going to focus on more in the pervasive 3D segment, which is where 3D content is created and the platforms and the systems that are built around that and the experiences. 3D content is already pervasive in retail, and it's often a good place to where virtual representations, of products are appearing everywhere, from ads, web, on mobile and computer, and AR, augmented reality, and virtual reality to mixed reality devices. And although 3D promises to be a very powerful merchandising tool, the challenge today is that not all 3D content can be experienced consistently across all platforms and devices. And this makes both production and consumption of these 3D virtual products, can be expensive and difficult to create and ultimately tough to scale. Next slide, please. And this is where the glTF ecosystem comes into play. So we develop glTF, which is a transmission, very low transmission, open source format. And the way we work is we look at the business cases that drive demand. Tools are created to support that, and you can see all examples of those on the left there. And then there's also a way to discover glTF files where you can download assets, and they're provided by 3D companies like CG Trader, Sketchfab, etc. And then experiences are created to utilize those. But today, I'm going to concentrate on just that bottom segment there. If you can move to the next slide, please, Lizzie. Where that we will focus on how the 3D Commerce Working Group drives demand and use cases and explores where the business need is. So yeah, let's go. There is a little video next, which will give you some examples of some of these use cases. Press play. So again, the Kronos Group is where 3D Commerce resides, and the 3D Formats Working Group resides, where glTF is the home of glTF and a lot of the PBR work. And some examples of that workflow here are, for example, the work done by Inversion of doing retail and looking at in shops and looking at the way products are created and viewed. Target's done a lot of work on building a lot of their library up in 3D. There's great work here for with Bremont watches, really high definition using CAD as a source to work with. IKEA have been working on 3D for a long time. And there's also how you bring these CAD files in and build room planners. This example here from Wayfair is building lots of different glTF files together to make a room plan. You can customize, you can configure, you can take a glTF file and build lots of different PBRs and materials, which ultimately gives the consumer and the customer the chance to make some bespoke solution. And of course, interactivity is an important part of this, which Gerald will come on to later. And there's other examples where you can configure, really high-end products. The work here, for example, done by Ventana for diesel and for stored clothing, where you can see these products up close and in detail with all the stitching. And then, of course, there's a lot of augmented reality use cases of seeing this product in virtual try-on And, it's good for consumers to see these products live on themselves. And that's, really evolving space. And it's an example here of what Snap have been doing about mixing reality of some, creative spaces and the real world around them. So the industry support for glTF is very big and very broad. There's a lot of e-commerce companies that already use 3D and already have 3D as either their main way of communicating with customers or certainly a complement to their flow. But today I'm going to talk a little bit about a particular use case. We go to the next slide, please, Lizzie, which is where a company called Ace Hardware, which is basically the largest retailer-owned hardware company or cooperative in the world, partnered up with Epigraph, which is a software company that specializes in AR and 3D configurators. The reason they came to Epigraph is because online shopping often lacks charm of the physical product, and the in-person shopping experience isn't quite the same. Everyone can also get to a store. Seeing your product with your own eyes, is hard if you can't ever get there. So this is where AR and 3D really takes, strong play. It has a high influential role in consumers' purchasing decisions. So Ace Hardware had a vast catalog, and there's different shapes and sizes and materials, and importance of keeping that experience simple, swift, and seamless. And the role of Kronos's group of glTF for the open standard for 3D visualization helped Epigraph meet those challenges and deliver Ace Hardware's customers a way of experiences through the web 3D solutions. So Ace Hardware also, prompted by the COVID pandemic, which would close a lot of retailers' doors, consumers began to browse sellers' online inventories, which was an urgency for Ace Hardware to make that experience as productive as possible through tools like AR and Web 3D and customization and configuration. And of course, AR lets these customers and 3D Web lets these customers view and interact and test these products in their own space. And I'll show you an example of what they've done here. And of course, with a demonstration like this, with the lawnmower and swapping different colors out and swapping batteries out and letting consumers really, maybe we can play the video again, Lizzie, sorry, if you don't mind, thanks. This really gives consumers the opportunity to really play about with the product and really see it in a web browser. You can spin it around and customize. Oh, here we go. That didn't work. So we'll just move to this next slide. No, it's fine, Lizzie. Don't worry. Thank you. So the interesting thing here was that Epigraph attacked each challenge using glTF open standard, which is obviously the 3D asset format. And Epigraph has relied on glTF since it began. And as you can see from this flow here, Epigraph focused on, they got CAD data from Ace Hardware, which was obviously any 3D content house will know that's the dream source of data to get when you're building assets. They used Pixies tool to decimate and create LODs because, of course, CAD data comes in with a lot of high resolution. That can be done manually, but there's some tools as well which will help you with that. But there's often a lot of hand-holding refinement that needs to be done there. Then that's been imported into Blender, where they've created the models and the textures, and they played around with the shaders. And then, of course, Kronos also provides some really good Blender import-export tools as well, which you can get access to. And then, of course, once they got the glTF files out to awaited a few of them, they applied some Draco mesh compression because the files were quite big, especially with the scenes there. And they played with a lot of the extensions that are available, such as Sheen and a lot of the other like clear coat extensions and transparency and index refraction extensions. But glTF gave Epigraph a lot of flexibility to be highly creative with optimizing these assets. And it made, actually, because glTF was their choice, it was a very efficient file format. So for larger products like this that required more rendering, glTF enabled them to use tiled textures, as an example, with scaled UVs, and create visual detail without requiring high resolution textures or additional memory. So when you bring in multi-SKUs, like you saw with the batteries, glTF's object instancing enabled significant savings on the file size and memory, and that eliminated the need to load multiple copies of the product. And of course, then Epigraph put this into their portal where they could have a CMS and build the 3D experience. And that enabled them to then show this product in however it was customized on AR, 3D, do product tours, customizers, configuration. Next slide, please, Lizzie. Thank you. And these tools have led to outstanding results for Ace Hardware. These figures are truly outstanding. Ace Hardware said that they've seen a 405% increase in conversion rate lift for those who engage with these solutions, as well as over a 500% increase in session duration on their website using these tools. And that's a huge number. We haven't consistently seen these numbers in 3D across the board, but it was really promising to see such strong figures of this use case. And it also, as you can see here, it gave customers, and especially their customers, a real ability to be able to actually customize, configure, see it around. And as you can see in the next video, please, Lizzie. Sorry, next, yeah, thanks. As you can see in the next video, consumers could then take these customized products, customize it on mobile, and then of course see it in augmented reality. I mean, AR is now something that a lot of people are more than used to. It's becoming quite a common use case. But for Ace Hardware, it created a huge amount of increase in sales. And also it really reduced their product return rates. They plummeted dramatically. And then consumers were much happier with their product purchase. And again, this gave them an opportunity to visualize their product in their space before buying, which actually also increased brand loyalty. Next slide, please. So the importance of standardization, if this demonstrative example hasn't given you enough, is that with visual consistency, you can get as close to the real thing as possible, which, as you've seen here, increases e-commerce conversion and online duration and reduces returns. But of course, very importantly, increases brand trust. You can see the same products across different browsers and different platforms. Next slide, next one. Then, of course, the glTF is a great format for processing and bandwidth. You know, that can be very varied. You can be moving around on a 3G, 4G, 5G connection. You know, you can be in Wi-Fi. I'm in a hotel right now. My Wi-Fi is not very good, you know, and still a glTF file will be easy to access. And glTF stores model information in a JSON format, which makes it a lot easier, minimizes the 3D assets and the runtime processing. And of course, the use of standardized file formats provides a consistent experience across a variety of devices and platforms. What is viewed on the web should be the same on another device, such as browsing and AR and VR and MR as well. And of course, as new devices become more readily available and more affordable, so does the need to bring a more consistent experience to those other types of space. And we are seeing a demographic change where that, you know, Apple's Vision Pro is coming out, Meta's Quest 3 is, you know, out already, and it's we're seeing more and more people understanding the potential of mixed reality, especially where you can walk around with a headset on and see your real world, mix it, or be fully virtual. And the demographic is changing, which is really good. So now go back. Sorry, Lizzie, go on. Thanks. So just to give you a little sense of what we're doing in 3D commerce, it's under development and current exploration. We've been doing a lot of really good research. Patrick from Snap has been doing some great work on exploring standards needed for facial anchoring and wrist anchoring and other key virtual try-on industries. This has been good work. There's been a lot of work here and digging into what the industry needs. We've been having some great conversations with different apparel companies and different types of tech companies of what their needs are. It's been quite a minefield for Patrick, dare I say. It's been a lot of complexity to the topic, which has been great. And we feel like we're now getting to a stage where we can put some standards out. Scene composition. There are lots of use cases for multi-skew. A lot of 3D has been shown a single item, but if you put multiple items together, how do you make those interactive? How do you light those? How do you apply physics on these? And how do you then provide those multiple experiences in an e-commerce solution that also then creates more inspiration for customer experiences? These are often developed bespoke by companies where they have to build something multi-skew themselves. And we're now looking into how to standardize that flow. Visual consistency, tone mapping and color is a very important topic, one that we're on to a lot at the moment, where we're looking at how tone mapping and color range displaying can provide visual consistency on a whole range of platforms and engines and browsers. We're starting to look into how do we take 3D files, throw them through a multiple range of browsers, engines and platforms, and see how we can get some kind of consistency. We're also finding that the color range and tone mapping solutions that are currently out there may be not enough. The human eye can't see some of these things, and some of the engines don't, a lot of the technology doesn't support the color range that's needed to make sure that that red of a chair is exactly the same red on every device. But of course, there are other things to add to that element, such as lighting, screens. I've got a spot lamp on right now, which is making everything look yellow to me, and we can't necessarily account for that, but it's an interesting topic we're opening up. We're exploring the needs for more tools and standards that can fully operate in conjunction with one another. The idea is build once, use anywhere to assist the ingestion of assets and scenes. We've already got a lot of great tools in Chronos, such as GeoTF Sample Viewer, Project Explorer, the Asset Validator, different tools, and we are using and developing that will make the whole ecosystem work a lot smoother. Then we're doing more tutorials, guides, and videos. We're doing a lot of work right now, for example, on what is the power of 3D in e-commerce? How do we share some numbers and data? How do we maybe suggest some things to maybe avoid? As a standards development organization, we don't say, well, you should do this, we should do that. We try to put out some ideas of, some ways to make your life better and make it more standardized, but make your experiences more usable. We're doing one-to-one interviews with industry experts to support the community, and we've just started that off now. So watch this space. That's going to be good. We're rebuilding the asset creation guidelines again. We had one out a couple of years ago, and obviously the industry has changed, engines and platforms change, things evolve, and we need to update that so that we can provide the industry some standardized guidelines to follow. And lastly, we've been doing a lot of talk and a lot of research and a lot of discussion on a hot topic, which is about NERF and machine learning and AI in 3D scanning and the use of generative AI in 3D asset and scene creation while following standards. It's a very developmental space. It's one that everyone's got their eyes on, but where is it right now? Can it be standardized? How do we scan and then make sure it flows into a glTF ecosystem, etc.? Thanks, Lizzie. And then if you'd like to join the conversation about scaling 3D in your own e-commerce solutions, please come and have a look at what we do. You've got some links there, or you can email us and learn more. Thank you. I will now pass over to the wonderful Gerald.
Thank you, Dan. Today, I'm going to present you the latest progress about the scene interactivity extension in the glTF. So first of all, if any of you has any question, please wait for the end of this session. There's going to be a Q&A for you. Next. Okay, so what is really interactivity? Interactivity is really the component that's going to bring your 3D content to life. That is really the thing that when the content dynamically reacts to user input. So a typical use case that was shown earlier by Dan is product configurators. Next. So in this example, you see a coffee machine that could be on a website for buying such item, and you can choose the type of model you want to buy, or you can choose the color. So by providing such a compelling experience, you increase the chance of having a buy from a customer. Next. So when you look at the current state of the art of glTF, the glTF format, glTF can only embed static scenes that are made of multiple sorts of assets, meshes, textures, and so on, even animation. But there is no internal rules to define how the runtime should basically deal with these assets. It's up to every player to decide exactly when such animation should be played. Should we also change dynamically some aspect of the content? So all these things are now are done outside of glTF. It's up to every player to define exactly how the interactivity is supposed to happen. So it's the main issue today that interactive content is not portable to other applications. Next. Adding interactivity to glTF, right? So on the left, you see a glTF as it is today. That is just a bunch of meshes and objects. And with the help of this new components of this new extension, the interactivity extension, you can get what you see on the right. That's the thing we just show, right? And so this new glTF extension really provides a blueprint for implementation of interactive assets, and it also empowers development of simple interactive application. That's really a shift of paradigm. Next. Next. Thank you. So let's have an assessment of all the how we build interactivity these days. I mean, so far it's been the most straightforward way, at least for engineers, was to write code. So basically, people would use a compiled language, C, C++, Swift, or could write interactivity through a scripting language like JavaScript, Lua, Python. So the issue with this is, of course, it requires some programming skills, and it's not easily portable. So on the bottom of this slide, you see some typical C++ code, right? That's used to be the way to implement such interactivity. Now, on the right part of this slide, you see visual scripting. It's a new way of programming behaviors that kind of emerged in the early 2000s. And the significant change compared to writing lines of code is basically the creator assembles and a bunch of predefined nodes, components to build a visually this interactivity. So it's much easier to learn for non-programmers because you don't have to compile, there's no syntax error. It's more portable because you only use basic building blocks that are provided by the system, and the system can define a limited set of nodes. And so, as an example, at the bottom of this screen, you see an example of visual scripting using Unity. And actually, what you see on the left, the C++ code where we wait the user to press the space key and kind of rotate an object by 30 degrees every 1 second, is translated in visual scripting on the right. And so the visual scripting is it's a much better tool for writing parallel programming involving time, and it's much easier to understand what's going on. It's a much approachable way of defining interactivity. Next. So that's for this reason that Khronos decided to implement interactivity as a standard through the use of a node-based graph. So a node-based graph, as the name mentions it, it's a graph made of nodes, and every node is doing an atomic operation. So this is a comprehensive feature set, like getting and setting variables of the world state. You have a branching flow, like the for loop, the while loop, the if that we call branch, and so on, and some logic like adding integers together or whatever. And that's been really popular these days. And we have two main industry standards like Unity and Unreal providing such concept. And also NVIDIA through the platform Omniverse and the OmniGraph is presenting also the same way of defining interactivity. So the extension, the KHR interactivity extension in glTF provide a standard specification for such graphs. So it's both accessible and powerful. The extension is providing a basic set of nodes, but by design, it's everyone will be able to extend this node by bringing custom nodes. And by design, it's really compatible with visual editing. Okay, so one thing important to note is Khronos is not providing any visual editor, but for sure we encourage people to build visual editors conforming to the glTF standard. Next, please. So some few principles of interactivity. An interactivity graph is really a graph. So a graph in computer programming definition, it's a set of connected nodes. And it's forming a directed acyclic graph. So basically, there's no loop. If A is connected to B, B cannot connect it back to A, whatever. So if you look inside a node, what do we have? So a node is defined by its type that basically says about the action being implemented, like adding numbers, listening to a particular event, or doing a branch or whatever. You could find also a configuration that are some constants. So some values that are immutable when you run the graph. that are configuring the node, and you have a bunch of sockets. Sockets are represented on the left and on the right. You have some sockets connecting inputs and some sockets connecting outputs. And among these sockets, you have value and flow. You can think value as data feeding the parameter, the node. For example, add node will have two value in for adding number A and B, and we'll have one value out for the result of A plus B. Okay, it's one category of socket value. The other category of socket is being the flow. That is defining the overall flow of the transition between one node to another, to define really the logic of the interactivity. Next. Okay, so instead of talking about high-level principle, it's always better to have a simple example. So what you see here is a very basic sample code where the purpose of this sample graph is really to go through the numbers 1, 2, 3, 4, 5, and for every number, send custom event that will send odd or even, depending if the number is odd or even. And after 2 seconds, when this whole operation is done, we send the custom node, a custom event node. So if you look at this graph, you see a bunch of colors that are indicating the type of node. For example, the blue nodes are really the life cycle. So you have the beginning of the node, which is called onStart. OnStart is really the node, the entry point when we start the experience. And that is connected to a for loop. So if you already know what a for loop is in C++, C or JavaScript, it's exactly the same. But instead of writing some line of code, you just put a node for loop, and you are just filling the information about the start index and so on. So I won't go into much details, but when you look at the for loop, you see that in order to figure out if a number is odd or even, we just compute the modulo with 2. So that's why you see this pink node logic modulo that is taking the current index of the for loop, and is doing the modulo of this index with 2, and depending if the result is 0 or not 0, we are either so that's the branch. The if is we chose the name branch instead of if because apparently it's the proper naming in the Unity and Unreal, and depending on the result of the incoming Boolean that comes into the condition socket, we either send odd or custom events. And on the bottom of the graph, you see that the done socket from the for loop is connected to the flow delay, meaning that after we executed all the iteration of the for loop, we go to the flow delay and we wait for 2 seconds before sending a custom event done. So that was just an example to get you an idea of what we talk about in terms of node-based graph and how we implement interactivity. Next, please. So what we've seen so far is just a basic way of doing a simple code like a hello world, which is using a for loop, if, and so on. But actually, the most important thing here is about glTF and bringing 3D to life. So we need a way to get and modify properties of the scene graph. So how do we do that? We provide. So first of all, there is a bunch of high-level nodes like play animation or stop or play audio that is referencing resources inside the glTF in order to play animations or play audio. I would call them really high-level nodes. But when it's about really touching and applying changes to a property of a node, let's say, so when I say node in this case, I'm not talking about the node in the graph. I'm talking about the scene node, the 3D node you see on screen. Let's say you want to modify the translation of to the position of a node. We use what we call the JSON path, which is a way of addressing individually every particular properties defined in the scene graph. So for example, if you want to access the translation of the 7th node in the glTF, GLTF being zero-based, you just use /node/6/translation. Same for the scale, okay? All these things, are possible because we are relying on another extension, which is called KHR animation pointers. That is bringing the JSON path system to GLTF, first of all. Next. Okay, so what can you do with this extension and why? Why this limitation? Just keep in mind that we have a few considerations to align with, like security, portability, and ease of implementation. And because of this, the first draft could feel a little bit limited, and we don't, maybe we're gonna add more stuff after the version 1, but that's why basically there's no way of dynamically allocating object, there's no array possible of variables, and we can manipulate strings, but only as constant. You cannot concatenate string or doing more complex operations on strings. We don't provide any nodes for accessing the network. We don't provide any nodes for accessing the file system, and there's no multi-user yet. So again, we are at the really beginning of bringing interactivity to GLTF. It's gonna be great because we'll be able to bring life to this content. And yes, that's it for today for me. And now Leonard is gonna present you the scene composition. Thanks.
Thank you, Gerald. I would like to remind everybody to post your questions to Q&A. That will be our primary means for answering your questions during our session in about 15 minutes. Next. So the idea of the composition originated with Adobe and also was part of the idea of interactivity that Gerard just talked about. It was presented to 3D Formats, which is the working group, the name of the working group that manages GLTF and a couple other specifications. We decided to separate out the work from interactivity to make it easier to manage. There was a lot of need for composition, especially from 3D Commerce, with room planners, as Dan indicated, and it was not all of that required interactivity. So through several efforts, including the initial form, we're now calling this GLTF external. If you saw the SIGGRAPH presentation, it was called GLTF composition. It's now moved back to GLTF external. Next, please. So initially, we're looking at 3 types of composition: a level of detail, which is either distance-based, which is sort of the traditional means, time-based, which means something may not be necessary to show right at the beginning of a sequence of animations, or it doesn't need to show at the end. And so that detail would be removed from the scene, or at least not included in what's presented to the user. And environment-based, which means that if you're running on a very low bandwidth or low powered device, such as a phone in a remote area, you don't want to, or you can't receive the full detail necessary or that you would want to see from a desktop system. So we're looking primarily at those 3 categories of level of detail. Streaming, of course, that's for large models, so you're not trying to hold up the entire display. You saw a little bit of that in the ACE hardware, where they presented sort of an orange outline of the toolbox before the detail of the came in. Smart loading, which is part of the environment-based, and also as you change the scene, including adding and removing objects, you want to make sure that you're not just putting those away into some manner that the scene still has to deal with them, but is not visible to the user. In other words, wasted CPU or GPU cycles. Next. So for the geospatial case, this is very much a level of detail based on distance, as this particular case is a point cloud data set. And as you get in close to various features, more resolution is provided. As you pull out, it reduces the resolution to where it's manageable, so you can still see the entire scene without having to deal with the super high volume of detail and data. Next. It's also useful for building information modeling, known in the trade as BIM, B-I-M, and where you don't where you may need to expose walls or the interior of walls to see where the plumbing, electrical, HVAC runs, but the regular user of that space that may need to be doing room planning would not have that information exposed. There's could be multiple reasons for doing that. When you're dealing with a user that does not need to see the interior space, you don't need to present that information to the user's device at all. So that's another form of level of detail. Next, please. And this is the room planning, selecting multiple products. Here you want to start being able to select the products. Next. And then move them into a full room where you assemble it, move things in and out. This is representative of a final version, complete with a full bookcase and everything else. Next. So one of the big questions is when you start lighting a scene, if you have one object, and let's call this object that we have in here, the box in the middle, lit with two different lights. Next, click please. So you pretty much know what happens. The stuff illuminated just by the blues light is going to be more bluer. The stuff illuminated by the red will be red, of course, and then the merge will be some sort of purple. But really the question, so the object case is pretty easy and you can embed that information into the individual objects. And so even when you compose a scene with two different light source colors and a third object that reflects those, it works out pretty well. Next, click please. But if you introduce environment lighting, such as the bamboo forest or a city light scene, next, what really happens there? And from a physical standpoint, you can put light meters and gather all the information there, but it isn't really practical to do so in a glTF sense. And right now, the feeling is that we will be proceeding with object lighting as indicated, where it's somewhat constrained, but environment lighting will be specified not at the individual scenes, but at the composition layer. Next. Billboards is the last part of what's being addressed in the current, in the initial phase of work. A billboard, for those not familiar with it, is something that is fixed to the display, at least to some extent. But as the scene is turned, and I know these are two different pictures, but it represents it, as the scene's turned, the billboard still continues to flag to the object and remain in the scene without having to look at the backside or just something that's really skewed to have the visibility. Next. So the initial work was done by UX3D. This was done about 4 months ago. As done as a prototype. At the time, things were called glTF X, GLXF for GL experience format. The name has gone through a couple changes to glTF composition, glTF-C. It is now, and this appears to be our final version, glTF external, meaning that the composition is based on external references from other image light sources, like a couple slides ago, other multiple scene compositions. So please run the video. And I have to click on the image. So this is their initial work, putting together multiple objects and making sure that we understood how the transforms work. But the primary work here is comprising objects. This is a lamp, the table, and the olive dish. With the olive dish has its own separate animation. By a simple change of the file that goes with it, we can add in additional objects, particularly the glass hurricane holder. It was necessary just to add that in. Then we're going to illustrate where these things are so they fit correctly on the table. When the scene gets reloaded, or actually when this particular example gets loaded, now you see the hurricane candle holder on the right. The olive dish is adjusted slightly. Okay, back to slides, please. You want, yes. So the next steps, we've talked about interactivity. The composition work is just starting. All this work is in our public GitHub. We will post the link as necessary in a little bit. We're doing a lot of prototype development, particularly with composition, since we're not quite sure what all the where the landmines are and where we're going to have to do significant work. At the same time, we're doing spec development. The spec development is being done within Kronos. The prototype development and exploration is being done by our contractor and partner on this UX3D. They're doing the work by extending sample viewer. So sample viewer, which you saw in the video clip there, is serving now as a platform to handle future GLTF work too. And those are the three initial topics: lighting, LODs, and billboards. Okay, so I'd like to remind everybody to put your questions and answers in the Q&A feature. While I bring in the experts, we have Dan Frith from Avataar. He's spoke at the beginning. Gerald Guyomard, who spoke on interactivity. I will be on, and Dwight Rogers will be joining us. He is chair of the Interactivity Technical Working Group. So Dan, please turn on your mic. There we
Hello.
go.
Sorry.
So
Again.
a question to everybody is, how can people help with this work, whether it be interactivity or composition or just general 3D commerce work? And Dan, since you started the show today, I'd like you to start.
Okay, thanks, Leonard. There's several ways actually to get involved. You can, we have something called the 3D Commerce Advisory Panel. That's the right word, isn't it, Leonard? Or is advisory forum, one of the two? Yeah, it's anyway. We'll put a link out to that where people can join a conversation. There's also a Slack and Discord channel. I also shared the email address, which is good to put in. There's also a way of we're going to hold more webinars as well, and we're also looking at how to, especially in 3D commerce, how to bring more community involvement into the work we do. So we're doing a lot of work at the moment in apparel, and how do we get people from the apparel industry who maybe aren't necessarily members of Kronos to contribute to that conversation. Dwight, Gerald.
Right.
So obviously, if anyone here is a member of Kronos or becoming a member of Kronos, feel free to join the group, the DTSG, we call it, on interactivity. We're always looking for more feedback there. We have our work going into PRs on GitHub. We're always looking at issues that people file there, and of course, anyone who's interested in making implementations or making content, it's great to see what people make and what issues they face as they try. So those are the ways I can think of.
Gerard, do you have anything else to add to that?
I'm fine.
Okay. And for composition, the work there is mostly being done at the prototype level in the Kronos GitHub. There'll be advances through sample viewer also available in GitHub. The spec work is internal at this time. What we will need for all the new work is examples. And so if you'd like to try your hand at some of this, even if it's not quite ready, we would appreciate any example attempts that you have. We have a couple sample repositories. You can always post an issue on any of the appropriate repositories for the work.
I'll post in a link for the advisory forum as well, with so people can click on it and see. And of course, people can join Kronos as well.
Okay. So to Gerald and Dwight, will there be a compressed format similar to GLB for interactivity, or to hold the interactivity systems?
We have not made a commitment yet to do any sort of compressed format of the interactivity graph. I think what we'll do is we'll look for feedback as this gets used about how large do these graphs end up being and how large are they relative to the rest of the file size. If that turns out to be necessary, we can look into it. But it certainly adds extra complexity, and if it doesn't seem that people create content that needs it, then we'd probably prefer to get a less complex solution out to everyone's benefit earlier, rather than add complexity and slow this down.
Anything to add, Gerard?
No, I agree.
Okay.
Nothing to add.
We've been saying that we're posting some links and other information to chat, but we've now realized that chat is not going to the attendees. So we're collecting this information, and they will be posted with the event page on this for this particular webinar. So come back in a day or so, maybe even later today, to see the answers, particularly for the advisory panel and forums and other links to the various repositories. Also, if you happen to be watching this as part of YouTube, the links and the important information will be in the description of the video. So I would like to answer the same question regarding composition. Composition files will also be available as a compressed format. And the group has not started working on exactly what that format is, but there will be a new binary format that supports all types of compression for glTF called glTF-B, but we have yet to work out any of the details. So that's something that's on our farther radar list. Gerard, there were a couple of questions and comments about the slides, and I think you have answered those in the system. Is that are you?
Yeah, so actually it was all about having not having a done flow on the branch. So basically the branch, which is a if, has only two output flow socket when the condition is true, and another socket when the condition is false. And what has been asked, like having a sequence of operation, and then in the middle you have an if, and you do something only when if is true, and after you continue, could be resolved by using a sequence node. A sequence node is basically executing in order a set of output flows, and in the configuration of this sequence node, you can specify the number of nodes that needs to be activated as an output.
Thank you, Gerard. To Dwight, what's the scheduled timeline for the release of the interactivity specification, or at least a draft of that?
Yeah, so a PR is available now that that is, I believe it's publicly available on GitHub. It shows much of the draft. It's got the basic framework of all the concepts, the node sockets, how those work. And it's got the list of all the nodes that we use for math operations. It does not yet have the nodes we use for playing animations and some of the other things that we'll need, but it's being updated about once every week or once every 2 weeks or so, with additional progress as we get the text finalized and everything. And there's another document that I believe is also public on GitHub now that defines the object model, which is basically everything that you should be able to access in your node graphs. The set of things in the glTF ecosystem that should be settable, the set of things that should be readable. I believe that's up as well. That one I think is considered pretty much done. If we get feedback from the public, then we may make changes, but we don't know of more changes we need to make there. And as I said on the PR, that one's being updated about once every week or two with new language to cover the rest of everything. And yeah, if you're interested in following along with it, follow along, post issues if you see them, and I guess how long it will take to be done sort of depends on how many issues people file, but it's definitely working along rapidly.
So this is something people will be able to watch and progress on our public GitHub repos as things go along and track along. And as it gets finished, we'll be very much interested in a larger community testing out and making sure that it meets the necessary needs. We do have a set of use cases that we designed these for, but that doesn't necessarily mean that it includes everything that you might want to do with it. And we may have missed something really important. So we're always interested in cases where the system doesn't work for you or doesn't quite address what you're trying to get done.
Just to add to that as well, that from the 3D Commerce Working Group perspective, we're working closely with Dwight and Gerald on the interactivity group and sort of looking at the business needs and how, the end user might want to have interactivity and then all the integrations and the different things that we're putting in there. So it's really good. So we're not just thinking about technology, we're also thinking about the business interactivity with it as well. So again, join that conversation. Maybe Dwight, I don't know if you've got a link to the GitHub repo and you can just post into the chat would be good as well, please. Oh, there we go. It's like you had it ready. Cool.
Oops, sorry, I'm on mute. I posted it, but yeah, okay, I posted it and someone else reposted it so everyone can see it. Perfect. And I do apologize. That particular link may have slight markup sometimes when there are equations and things of that sort that are supposed to appear. I believe it has markup that describes the equations. There's another link to the rendered version that has the equations looking proper, but I think I don't have that link off the top of my head. If I can find it, I'll post it, and then you'll have one that's prettier, but all the text is there, so it should be pretty clear.
There's a nice thing in the questions and answers as well about someone saying it's good that we're pushing forward with GLXF. I think there's a motion to maybe change the name a little bit, but we're going to see how that evolves. But the fundamentals are still the same. It's going to be good to. There's definitely a need for having interactive objects and multiple objects in the scene. Which is good. It's the evolution of 3D and interactive content.
So we will continue to be available through the GitHub repos. Just create an issue. If you have any questions, feel free to use the Kronos contact form and I'll make sure it gets distributed to the correct person. We want to thank everybody for joining today. I know your time is valuable and we hope that you learn something and can continue to pursue on this.
Yes. Thank you, gentlemen, for all your time and effort in putting this together. Just to let everyone know, we have more GLTF webinars coming up on October 31st. Join us for Let's Get Moving, adding physics to GLTF. And on November 14th, join us for standardizing body attachment points for 3D Commerce virtual try-on. Also on our website, we have recordings from 2 recent GLTF webinars on unleashing creativity in 3D models with GLTF and PBR and optimizing GLTF. Check our website to register for the upcoming webinars and access the recordings. As you leave the webinar, please take a moment to fill out the survey form that pops up. Your feedback is important to us and helps us improve these presentations. And please let us know if there are other Kronos-related topics you may be interested in. Thank you for joining us and have a great day.
Thank you, everyone.